Hi everyone. This is a continuation of quiz 3 revision, and here we will be discussing about week 9. So the topics we will be covering will be random variable, probability distribution, and discrete and continuous random variables with functions of random variable. It's mainly graphs. Further, we will be also doing some questions. So let us start. Random variable. First of all, let us define Z, which is for an experiment, any random experiment, uh, number of total outcomes possible would be defined as elements of set Z and will be denoted as Wi, where I belongs to 1, 2, 3, and all positive numbers. So, what is a random variable? For a sample space where S is a subset of Z, a finite single valued function that maps into Z into a real value is called a random variable. This means that a random variable signifies the outcome of the element in Z. So we can denote random variable accordingly. For example, a dice is thrown twice. So we define a random variable as sum of the sum of the outcomes on the dice of the experiment. So uh, x is a random variable. Here's a condition: if and only if for each x belonging to real number, here's the element and x. This means that random variable on the element is less than x, which also means that x, random variable x, is less than or equal to the quantity x, like which belongs to real number values. This means that if the sample space set forms number of x number of outcomes, then random variable, whatever random variable we define, will always be less than or equal to the small x. This means the random variable will be less than or equal to x. So if x is a random variable, the sets x less than or equal to x, a and b be any constants which belong to x. So let me write it like this: a comma b or a is less than b is less than x. So given this condition, x will always be less than or equal to the random variable. Sorry, x will always be greater than or equal to random variable. Random variable can be between the interval a or b, given that a and b are less than x. So what I am trying to say is that we can define a random variable through these different sets, which are all events, and from this we interestingly observe that we can use all of them to define the random variable. For example, x is random variable if and only if x, random variable, is less than the x amount of outcomes. So the unique part here is that while we define the random variable, the notion of probability is not discussed. Actually, some people who study random variable have many doubts in what does the random variable signifies. So for that, I should give you an example. For example, let us suppose a coin is tossed n times. Okay, so what we have to do is to signify x, which means that the outcome is head. X is a random variable which says that outcome is a head. Or you can say x is a random variable that signifies number of heads. Sorry. Number of heads. So see here. Here, this small x is n, which is less than or equal to x. Now, if a coin is tossed n times, x can at max be n, but it will always be less than or equal to n. Like it can be 1, 2, 3, 4, 5 up to n. And let us finite this draw. So let us suppose rather than n, we are tossing it 5 times. So here we will write it that x is a random variable if and only if for each, of course 5 belongs to R, so we will write it as omega x element, random variable of element is here 5 less than or equal to 5, x is less than 5. So what values can x random variable take? It can take 0, 1, 2, 3, 4 and 5. These are the total number of values x can take. I hope you understand what a random variable is and what does its definition mean. Because sometimes in question is given in such format and the student is not able to understand the question properly. So you must know the correct interpretation of this notation. Now, here's, yeah, I already told you that in random variable we didn't discuss the notion of probability. So therefore, continuing the concepts of random variable, for any set A belonging to superset Z, x a omega equals to 0 or 1. This is Bernoulli's uh, interpretation. So x a is a random variable if and only if a is a subset of Z. So let us just start with the question. This will allow you to understand. Now let x be a random variable. We have to find, is x raised to power 1 by 3 also a random variable? Yeah, by the definition we said omega x omega less than x. So for x belonging to R, we said that. Okay, so let us say that here, if we are making x into a function x raised to power 1 by 3. So x raised to power 1 by 3, for x be a real number, will always provide a real number. So we say that x raised to power 1 by 3 is also a random variable. Here, if the question was that is, because if x is a random variable, it is a real, and real value cube root of a real value will also be a real value. So if the question would be x square plus let us just say xi, where I equals to this. So is this a random variable? Of course not. It is not a random variable. So now, is x plus 1 a random variable? For x being positive, see, if here this condition would not have been given, then we wouldn't be sure that x is a random variable or not, and because of uncertainty we will just say that x wouldn't be a random variable. But now here a condition is given, so as long as x is positive, uh, square root of a positive number will always give a real number. Therefore this is also true. Yes and yes. Now this is an interesting question. How to remove this? Sorry. Yeah. So question is a superset. Yeah. Outcome of a random experiment is between the interval 0 to 1. So let S be the set of all subsets of Z. So given that x omega is something like omega for omega between 0 to 1 by 2, and omega 1 minus 1 by 2 for 1 by 2 to 1. So is x and are we getting a real value under every circumstances for x omega? Yes, we are. So this is a random variable. Now what is event x x omega belonging to 1 by 4 to 1 by 2 interval? So here first of all we will draw a graph of x omega x omega from the start. uh, it's just linear graph till omega equals to 1 by 2. So let us suppose it's 1 by 2 here, and this is also 1 by 2. So x equals to 1 by 2. At x equals to 1 by 2 we will get the value 1 by 2, so I have marked a dot here. Now at x 1 by 2 positive we will get the value 1 by 2 a bit positive, a bit more than 1 by 2 minus 1 by 2. It will be approx to 0. or we can just use the limit x 1/2 positive, where x tends to omega tends to, sorry, here omega tends to 1/2 positive. What we have to find the value, so it would be 1/2 minus 1/2, which will be equal to 0. So here we get a value 0. From there, x1 will have value 1 minus 1/2, which is equal to 1/2. So from all of this, a graph will be defined like this. Here at x equal to 1, we are again getting 1/2. Now, first of all, mark me this. There's a drop here. So now here is 1/4. What we have to find that x omega belongs to the interval 1/4 to 1/2. So let us draw x omega equal to 1/4, as we actually have to draw for x equal to 1/4 and x equal omega equal to 1/2, but 1/2 is already drawn on blue line, so we need to make more efforts for this. Yeah, see. So this upper region, which is colored by orange, contains the interval x omega belonging to 1/4 to 1/2. Now we already know that this point is 1/2 comma 1/2. This point is 1 comma 1/2. Now we have to find these. So at x, for what value of x omega we will get 1/4. We know that for omega less than 1/2, x omega equals to omega. So here the omega will be 1/4. So from this we get the value 1/4 here. Now we have to find the value here. It is 1/4, so 1/2 plus 1/4, here we will get the value 3/4. See, this 1/4 lines cuts here, so of course we will get the value 3/4. Or you can just say it like this: for what value of x omega equals to 1/4, for x omega equals to omega minus 1/2, which is equal to 1/4, omega equals to 3/4. You can just write it like this also. So this is 3/4. Now our question was x omega belonging to interval that interval 1/4 to 1/2. So this is one, my colored, where I am coloring this portion and this portion. On number line we can see that it is 1/4 to 1/2 union 3/4 to 1. If you have any doubts, contact me through comments. Now next, uh, this is getting troublesome. Yeah, so the probability distribution of a random variable, a real valued function f defined from minus infinity to infinity, that is real, that is non-decreasing, and it is continuous towards the right side, which satisfies that f of minus infinity will be 0 and f of infinity will be 1, is called a cumulative distribution function. This function is best when defined with example. So let me give you an example here. Let us suppose a ball from an urn of three, with the three balls, three distinct balls numbered, which were tagged. So we got an on we have an on. Perfect. There are three balls, 1, 2, 3. Okay, and there's an equally likely probability. So let us give it 1 by 3, 1 by 3, and 1 by 3. Okay, now let us define a function uh, which is p of x less than equal to x. This will be when an ball is drawn, ball is not drawn, that will be x will be less than 0, less than or equal to 0, a value will be 0. So when ball is drawn and we got an urn, a ball number 1, so what we will write it like 0 x equal to 1, 1 by 3, 1. Then second ball is chosen, x 2, so it will be 2 by 3 here, it adds up. So third 3 by 3 for 2 x 3. So this is, here f of x is cumulative distribution function. I hope you understand this. It is not necessarily that ball was supposed to be number 1 and it uh, was chosen number 1. It was that the after the outcomes we can know that it is 1, 2, and 3. So it's just a sake of simplification. We can understand more with the help of definition. So we have already done limits in maths. From that you may already know that if f of x is non-decreasing, we will get this, that limit of x negative will be less than f of x will be less than f of x, limit of f of x positive or equal to. Okay, now Here, if f is continuous, f is discontinuous, we will have a jump point in cumulative distributive graph. As we can already see that the values are increasing: 0, 1 to 1 by 3, 2 by 3, and 3 by 3. So as values are increasing, let's suppose this is a graph. So a slope can be 0 to infinity, so the values will always increase, and from this we can say that whatever discontinuity will be there, like this, we will get only upwards discontinuity, not downwards. It would not be like this. First of all, my graph is wrong. It would not be like this. So it's a downward continuity. Okay. Now, there will be a jump point if and only if f of x positive is not equal to f negative, but they exist. It's just a basic math. So you already know this portion. Here we can just come up to how to write CDF. So we just write CDF in this form: f of x equals to p of x less than or equal to the outcome. So here, like I have written, f of x equal to p of x less than or equal to x. Okay. Now let us just come to example. Let z superset with ij, where I and j belongs to 1 to 3. It is just a dice. Dice is thrown twice, and we get probability of ith and jth outcome will be equal to 1 by 6, 1 by 36 for all 36 pair. It means that when a die is thrown, there are equally likely outcomes. So we have to define a random variable ij for I plus j, where I varies from 1 to 6. Now here see, f of x is equal to random variable x, which is less than or equal to outcomes. So here, first of all, at x which is less than 2, which is not possible, because x less than 2 values will always be 0 or 1, and 0 or 1 do not specify for I plus j. So our possibility will be 0. For x here, this value, it means that x is 2. For x equal to 2, we will get pair 1 and 1. This is only pair between 36. So from 36, so we will look 1 by 36. Now for x equal to 3, we will get pair 2 comma 1 and 1 comma 2. There are two pairs, so we will add 1 by 36 plus 2 by 36. Again, for x equals to 4, we will get 2 comma 2, 3 comma 1 and 1 comma 3, which will be 3 by 6. So 3 by 6 plus 3 by 6 will be 6 by 6, and this will continue further till we get the value 1. Now let us come up with discrete and continuous random variable. Discrete variable is analogous to number of outcomes, and it is countable number of possible values, whereas continuous refers to the amount. It is generally a ranged value which is infinitely divisible, like we did in this question. It's a continuous, and whereas in this question it was random, discrete random. Now let us come to probability mass function. So here's the definition: collection of number pi satisfying x equal to I, x equal to xth I, which have the possibility pi and the possibility is greater than 0 for all I. This means, let us come here. Even though it's a cumulative distributive graph function, we can see that at x equal to 2, it means here that, first of all, what will pi be in this question? In this question, pi will be 2, 3, 4, 5, 6 up to 12. Okay. Now for x equal to xi2, p of x equal to x2, we have a pi will be our 1 by 36. So let me just increase the area. I hope you already know what are the values of xi. So xi will take the values 2, 3, 4, 5, 6 and 12. So here p of x equal to x2 will be 1 by 36, which is p1. P of x equal to x3 will be 2 by 36, which will be p2. P of x equal to x4 will be 3 by 36, which will be equal to p3. P of x x5, we didn't discuss this one now, so we will have the outcomes 4 1, 1 4, 3 2 and 2 3. So 4 by 36, p4 x equal to x6, this will be 5 by 36, p5. This will continue further till we get x equal to x, outcome number 12. So this will be 1 by 36, because only one outcome will be possible, which will be 6 by 6 comma 6, and this will be p12. Oh, sorry, p gave wrong notations. So p2, p3, p4, p5, p6, p12. So here we got a collection of numbers which are there. They satisfied p of x equal to xi, which are there, and they all have the value p of I is greater than or equal to 0. Now why didn't we consider p1? P1 also have a reasonable spot here. Here this one will be 0, which will be p1, because it is 0 because p1 this doesn't have any outcome. Now for all I, we did from 1 to 12, and sigma I equals to 0 to infinity pi equals to 1. Here we needed to use infinity. We can just say that p of I equals to 0 from up to 12 of pi will be equal to 1, which will be true. You can see that 1 by 2, 1 by 36, 2 by 36, 3 by 36 up to 1 by 36 again will be equal to 1. All of those values will constitute to 1. uh, an interesting fact is here that this value here, like we add up consecutively term by term, so at last we got the value 1, which is sigma I equals to 112 pi this value. And as we already said in PMF, this value will give 1. Now here's an example. Let x be a random variable with a PMF. This is the PMF of random variable. So x equal to k outcomes equals to 6 by pi square into 1 by k square. K can take 1 to infinite values. So f of k will be this. Constant will be removed outside and we will have summation of all of this. And from this we end up PMF. So it shouldn't be here. Okay. Yeah. From the previous result, that is from here, okay, from limits, we can also conclude that if an interval a to b has n finite discontinuities, let us name those n discontinuities x1, x2 up to xn. All those discontinuities will lie between the interval. So a is the of the least magnitude and b is of the highest magnitude. So from this we can say f of a will be less than, here we are using the function, we are using this property. So let us just overview this. F of x1 negative, this means the limit x tending to x1 negative. So f of x1, and we are only using negative terms, assuming that fb is just above the xn. Let pk be equal to f of xk minus f of xk negative for k up to from 1 to n. This result is important now. Summation of all those values, all those differences will always be less than or equal to fb minus fa. Means the difference between the y terms, or you can say difference between the intervals of the function, will always be greater than or equal to summations of the this term. You can just write it like this. It is just it's common sense, you can say. So even though this isn't coming in exam, this can be used to strengthen your concepts. So let us come up here. If f of x is absolutely continuous, that is, if there exists non-negative function f of x for every real x belonging to a to b, then here comes up probability density function. F of a for interval a to b gives this. Okay. And now you say where this come from. Actually, this comes from both this and this. So at the last, whenever you are asked like p of 0.3 x, p of 0. P of 0.3 x 0.8, You can just simply write it like, put it in function, what is the value at f of 0.8, and subtract it from function at 0.3. You will get your value. Simple. This is most important. It comes in question, and it will be of great much more use to you. Seriously, this is really important. Now, okay, see here, it came up. So first of all, we have been given CDF of f, which is in form of 0, x and 1. Okay, so to find the continuity points of f, we will first differentiate them, okay, because we have to find the slope now. So see, first of all, after differentiating this, we get constant gives differentiation 0. So x at x greater than 1 or x less than 0 or equal to 0, we will get the value 0 here, because they are constants. Now here's a dilemma. We know that f function is not continuous at x equals to 0 and 1, because the slopes are different. So we can define it accordingly, that f of 0 equal to f of 1, which have the slope 0 at x equals to 1. So we have, first of all, we can generalize this. This will be a PDF graph for this will be a PDF function, so we can just create a graph from this. Now coming to the main part, the formula I told you about, P of 0.4 to 0.6 will be f of 0.6 minus f of 0.4, which will be 0.2. We can just write it at f 0.2, 0.6, 0.4. Now I will be explaining this part in the next slide, where a graph is given. Yeah, so here, this is the point. Here it is discontinuous, and at here it is discontinuous, because actually we can't say that it is discontinuous. Thing is that slope of this f of function is discontinuous at 0 and 1. So you can't say whether at x equals to 1 slope is 0 or 1. You don't know. Rather, you can just say it's 1 by formula. You do get 0. So, man, I'm confusing myself. All in all, the slope of f of x is discontinuous at x equals to 0 and x equals to 1, because at x equals to 0 and 1 we get 0, and for other points from x belonging to 0 to 1 we get value 1. So here's the graph. You can understand it yourself. So it is pretty simple. Now let there be a k be a constant greater than 0. This is given, so we have to find p of x greater than 0.3. We'll just use the previous formula, this one, put it in here, constant comes outside, we integrate it, get x cube by 2 minus x cube by 3, have a value k by 6. This defines the PDF. So for as integral of the PDF gives the area, like for this function, let's suppose the graph is something like this. So the area the integral refers to area, and the area of PDF is always equal to 1. So if k by 6 comes up, we will equate it to 1 and get k equals to 6. Now to find the value probability of x greater than 0.3, what we will do is to subtract the probability of x less than 0.3. So what I did is this value will be 1 minus p of 3. Now you say why we did it? Because this function is always defined for less than. So 1 minus 6, you can yeah, so 1 minus 6, 0 to 0.3 x 1 minus x dx, we multiplied it, so we just get the same thing here and put the values. So 0.3 square by 2 minus 0.3 cube by 3, we use this and got the value 0. This gave us the value 0.216 when multiplied with 6, and at last we got 1 minus 0.216, which gave 0.484784. Now here comes the probability mass function. This is how probability mass function looks like. We already solved question regarding this. Now 1 by 6, 2 by 6, this is pretty familiar example. We already did for 1 by 36, 2 by 36, 3 by 36 for the previous question, up to again it came for p12 equals to 1 by 36. So yeah, it is kind of analogous to this one. We will have same graph, and note that summation of all the pi will be equal to 1. So you can just calculate it. 1 by 16 plus 2 by 16 plus 3 by 16 plus 4 by 16 plus 3 by 16 plus 2 by 16 plus 1 by 16. Here 6, 4 and 2, 10 plus 4 plus 2, 16, which will be 16 by 16, which is equal to 1. See, probability mass function on all will have summation equal to 1. Now for probability mass function which was on discrete values had summation, and here in probability density function which is defined for continuous random variable will have area under the graph equal to 1. This is area under the graph equal to 1. In this case, for this graph 0 to 2 f of x dx will be equal to 1. Okay, so this area, total area, will be equal to 1. Or you can just write the geometry. The height of the triangle is 1, h equals to 1, base is equal to 2, so area of the triangle is half into base into height, which is equal to 1. Simple. So this is all about the probability density function. Yeah, you have to it is recommended to draw the probability density function because it is easier to find the tricks to find the area. Like if you didn't draw this graph, you would be stuck on the integration, and time taken to solve this question would be more, rather than if you solve this question by drawing this graph, which is pretty useful, you just got your answer in seconds. It's just a recommendation. You can do as you like in exams. Now, let us solve some questions. First of all, it is given that a continuous random variable x has a probability density function f of x f of x equal to a plus bx x 5, otherwise it is 0. Okay, so what we have to find is, rather than finding, it would be better to change up the question. So let us say question is, show (10a plus 25b equals to 2). We have to prove this. So first of all, we will find the values of a and b. From we know by a definition of PDF that for a to b, f of x dx equals to 1. So we will use it here. 0 to 5, a plus b x dx equals 1. We will use it. Ax plus b x square by 2 from 0 to 5 equals 1. So put the values. 5a plus 25 by 2b, here it is minus 0 plus 0 equals 1. We get 10a plus 25 10a 25b by 2 equals to 1, or 10a plus 25b equals to 2. Proved. But in exams we are supposed to give values, so let us just remove all of this or come up here. Yeah. Let us go with another question. We have a PDF of f of x equal to 3 by 32 x k minus x, where value goes from 0 to k, otherwise we will get the value 0. So find value of k. This is a usual question exams. Okay, what we will do is, again, for a probability density function, we know this formula. I already told you that this means that the area under the graph is 1. So using it, 0 to k, 3 by 32 x k minus x dx equals to 1. To k, 3 by 32 is outside, xk minus x square dx equals to 1. 3 by 32 x square k by 2 minus x cube by 3 k to 0 equals to 1. Put the value k. So 3 by 32 k square k cube by 2 minus k cube by 3 minus 0 will be equal to 1. Amazing. So we got after this 3 by 32 equal to, sorry, 3 by 32 k cube by 6 will be equal to 1. K cube by 6 equals to 32 by 2, 3, and okay, so k cube equals to, sorry, I messed up. It is 3 here and 2 here. So k cube equals to 64, k equals to plus, k equals to 4, as cube root of 64 is 4. So here k equals to 4. Now and there is another question. F of t equals to c 81 minus t square and 0, otherwise, and the value is for 0 to 9 and 9. So first part of the question, find c. Second part, find CDF of f of t. So we will do the first question. Again, it is simple. 0 to 9, c is outside, 81 minus t square dt. So we will get c, which will be equal to 1. So c 81 by c 81t minus t cube by 3, 0 to 9 will be equal to 1. C 81 minus 9 cube will be 729, I suppose. Yeah, 729 by 3 into minus 0. So 81 minus 0 equals to 1. Again, there's something wrong. Here it's t, so it would be 729, and here it will be 0. So this whole term will vanish. 0. So we just get c into 729 by 2. No. It would be 729 into 2 by 3, which will be equal to 729 into 2 divided by 3. 486. C equals to 1 and C equals to 1 by 486. Okay. Now we have to find CPF. C, it is CDF. It is CDF. Okay. So B part. As I told you before, graph is must, or you can say try to make the graph of these functions. In this case it would be 0 f of t. So you can say see that c81 minus t square is a quadratic equation. So what is the 0 of the quadratic equation? You can see c 9 minus t, 9 plus t, t equals to plus minus 9. So we have to just uh, concentrate on the positive signs. So here 9, it will be 0 on 9, so this point, and this will be 0 at c of 81 minus 0 equals to f of t, yeah, f of 0. So it is 81c or 81 by 486, you can say. So the graph will go something like this. Okay, so what we will do, first of all, we will say f of t equals to p of capital T less than or equal to small t. Now what is small t? This will also help you to understand this unusual format. So let us suppose there's a t here. So this thing means that this is p t less than or equal to t, this shaded area. I hope you understand. This whole area means p of t less than or equal to t. So what we will do, when t is between 0 to 9, f of t will be equal to 0 to t 1 by 486 from the previous result, 81 minus t square dt. This will be equal to 0.148. Let us just take it outside. So 148 1486 0 t 81 dt minus 0 t t square dt. So this will be equal to 1486, and this will be 81t minus t cube by 3, 0 to t. Now we will just substitute the values. This 0 will just come up with 0 value. So 1 by 486 into 81 t minus t cube by 3. Let us just not multiply it whole. So, or even after multiplying, let me see, 81 48, this will be 6, and 486 into 3, 86 into 3, 86, 1458. So we can make a cumulative distributive graph. F of t will be equal to p of t less than or equal to t, which will be equal to 0 when t is less than 0, because here we mentioned t greater than 0. To less than 0, it would be 0. For 0 t 9, we will get, what is this? We can rewrite this whole like t by 6 minus t cube by 1458. So t by 6 minus t cube by 1458, and 1 if t is greater than 9. This is cumulative. Simple. I hope you understand. Last, I'll give you a homework question. Try solving it yourself. There's a continuous random variable x, and PDF of this is f of t. Let me just write it properly. It is kind of confusing now. So the find p of x less than or equal to, let's say, 7. So this is the question for you guys. Try solving it. If you have any doubts regarding this, contact me through comments. Thank you. Have a nice day.